So in this video, basically it's just a picture of what I took from the board in class. And what I did was I just basically put the three types of plate boundaries on the board, and I summarized all the different points that are associated with each one. Now the biggest thing that a student needs to do when we're looking at the different plate boundaries is you need to group things in your head that belongs with each specific type of plate boundary. And you cannot use those things for the other plate boundaries. Otherwise, your answers get all mixed up and your multiple choice all get mixed up. So for example, if we look at a transform plate boundary, the plates simply slide past each other, and they slide past each other based on what the convection currents are doing beneath. It creates shear forces. And so because the plates are just simply sliding past each other, there are no volcanoes. But every single time when those plates jump or shift due to a fault and the movement, we could possibly get earthquakes. So two places that are most common for this type of plate boundary in our world would be known as the San Andreas Fault in California and the Alpine Fault in New Zealand. So if you were in the San Andreas right now, at the San Andreas Fault in California, there's probably nothing taking place. There's no volcanoes to see. The question is how much shear force is built up on those two plates, and when will they make a move and slide past each other? When they do, an earthquake will result. Now, a lot of times when this movement occurs, there's a lot of heat and pressure and hot chemical fluids. So anywhere along that plate boundary, it is possible to get some low-grade metamorphism take place. For a divergent plate boundary, the plates are pulling apart from each other based on what the convection currents are doing down below. So one convection current takes one plate one way, and another convection current takes the other plate the opposite way. And that puts tensional forces on both plates, and they pull apart. When they pull apart, lava comes up from beneath and goes to volcanoes on the surface, and lava comes out of those volcanoes and solidifies to create new ocean floor. So it's divergent plate boundaries where new rocks are formed. It's the newest rocks in the world, and the feature that is located at this plate boundary is a ridge, and a ridge is mostly due to the magma beneath pushing up on the edges of both plates. It is at a ridge where the process called seafloor spreading occurs. And seafloor spreading occurs at a rate of about 2 centimeters per year. So for example, we know that Europe is going away from North America at that rate at about 2 centimeters per year. Because of the tension that's exerted on both plates, if rocks actually snap and break anywhere in this type of plate boundary environment, typically the faults that you get will be normal faults. And a normal fault is defined by when the hanging wall drops and the footwall rises. So hanging wall moves down, footwall moves up. Now you may not understand your faults at this point unless you would have done a world geography course before, but that's fine. Right now I'm just trying to group normal faults with tensional forces at divergent plate boundaries. Examples of this in the world would be like Iceland and Surtsey, which is right down the middle of the Atlantic Ocean. Also, we get divergent plate boundaries along the Indian Ocean. For convergent plate boundaries are when two plates come together, and when both plates come together, we get compressional forces. Now, the type of volcano that you actually get here really depends on the type of collision. So really, we can get an ocean plate colliding with an ocean plate, or an ocean colliding with a continent, or a continent colliding with a continent. Examples around the world where we get an ocean-ocean collision is the Aleutian Islands, the Philippines, and Japan. And the Rockies and the Andes would be examples of an ocean-continent collision. And the Himalayas and the Appalachians would be two examples of a continent-continent collision. The one thing that is most significant here is that at all three types of collisions, you will get a trench, and the process of subduction will be occurring or will be just completed. And you'll see what I mean by that when we look at each of the different boundaries. So we need to associate subduction and trenches with the different collisions. And because there's compressional forces pushing on rocks, if the rocks are to snap, then the type of faults that you will actually get here is reverse fault or thrust fault. Now, if you think about it, and if you go back to a divergent plate boundary right here, we said that's where new rock gets created, so the newest rocks in the world. And if you have seafloor spreading going on, well, then you would think that the Earth would actually be getting bigger in size. So naturally, if new rock is getting created somewhere at like a divergent plate boundary, then somewhere else rocks must be getting destroyed. And they get destroyed when they go down a subduction zone at a convergent plate boundary. So This is my attempt to group these different processes and things together within the three different types of plate boundaries.